Let's learn in this video how to create a Kubernetes cluster in Azure using the AKS Azure Kubernetes service. Then we go to deploy, pods, deployments, and services inside the cluster and see how these components work together. Let's start first by creating an AKS cluster using the Azure portal. So from here, I'll go to the Azure portal, create a new resource, and then choose from here the Kubernetes service. That will bring the template for creating the service which will go through those different steps for customization. So first I need to choose the subscription, then the resource group. I choose the resource group name, and then for the cluster pre-configuration I'll choose the standard one, and then I'll give a name to my cluster, aks.cluster for example, and then I'll choose an Azure region. Let's go with West Europe. And then we'll go to choose the availability zones. So this means that the nodes or the VMs in my cluster will be spread across those different availability zones. So I take here 3 availability zones. And then I choose the Kubernetes version. So by today, the latest Kubernetes version available is 1.23, and we have 1.24 available in preview. If you are watching this video in later time, then maybe you will see some other newer Kubernetes versions. So let's continue with 23.5, and then for the API server availabilities, this will help you to add SLA to your control plane. So we don't need it in this demo, so I'll just go to optimize for cost. And then for the node size here, I continue with this default one, DS2 V2, which has 8 GB of memory and 2 virtual CPU. I'm okay with that for this demo. And then for the scale method, I go to auto scale. So yeah, from 1 to 5 VMs. Actually, I'll take from 3 to 5 VMs. Okay. That's the number of my nodes inside the cluster. And then next, if I go to node pools, so by default, the AKS cluster will be created with one single node pool, that is the call it agent pool, that is of type system. It means it will host also the system pods in addition to the customer pods or the application pods. And it's running Linux. It should have at least one pod or one node pool running Linux, and it would have the number of VMs that we have specified earlier, the availability zones, and it would have a max number of pods, which is going to be 110, and that is the default value, but that could be changed from the command line. But of course not changed later. It should be chosen when we create the new node pool. If we created the node pool already, then we cannot go and edit that value. Then we have some couple of other options like enabling virtual nodes. This will enable Azure Container instances to help the AKS cluster to scale out its pods immediately within just a few seconds by activating the ACI connector. And then some other options for security like encryption at rest and so on. Let's go next for the access. So this will set up how the cluster could be accessed or how the cluster could access Azure, other Azure resources. So the cluster would use an identity to create Azure resources like the load balancer, like the virtual network, managing the application gateway maybe, and so on. So that identity could be either a managed identity, like a system assigned managed identity, that is the default value per today, but that could be also a service principal, an SPN, and that is the old deprecated option. Airbag role-based access control. So we have here this option to enable it or to disable it. Of course, here it's a good practice to enable it and also to enable using Azure Active Directory, and then you map an Azure Active Directory group to be the administrators of that AD. So you select one of your groups and you are good to go. So for this demo, to keep it simple, I just go to disable Airbag to make it really easier to access the cluster. And then next, for the networking section, here we have the choice between the two networking configurations. So basically with all of my customers, we spend like hours discussing what is the difference between the two, what are the advantages, the disadvantages, and so on. But to take it easy, the Azure CNI have, let's say, more options than what are available with Kubernetes. Kubernetes is the default option for networking inside Kubernetes. It's the default option, so it's simple to configure, but with Azure CNI you get a little bit more options, and it's a little bit more performant in terms of performance, because the difference with Azure CNI is that each pod will get an IP address within the virtual network of the cluster, and when it have that IP address within the virtual network, it means it will connect more fast to other Azure resources that are connected to the same network. So here I continue with Azure CNI. Let's say that's the default option, and then with it we can actually bring our own virtual network. We can also select the default subnet we want to use, the ranges for the service address, and so on. So this is going to be the IP ranges for that will be used by Kubernetes in order to create the services or to expose the services inside the cluster itself. So that IP range should not overlap with the cluster subnet range, okay? And here are some other configurations like the DNS service IP range for Kubernetes. Next in this section here we have the traffic routing. So here we'll be using load balancer with the standard, we'll be using the standard load balancer, that's the required configuration. And then we'll go here for enabling this HTTP application routing. Note that here this is only for development, and it's not recommended for production clusters, so we will not activate that actually. And then we would have here the option to enable a private cluster. So by default the cluster will be accessed, or the API server of that cluster, of the AKS cluster, will be accessed publicly. It have a public endpoint. We can disable that public endpoint and enable a private endpoint, and with that option we can access to the cluster only from within the virtual network of the cluster. So this is different from exposing the services. So I can still expose a service publicly to the internet while having a private cluster. So here the option for private cluster, it means to access the API controller of the cluster. It's for my DevOps pipelines, for my DevOps teams, for my developers who wants to access the clusters. They should access through a machine that have access to the virtual network of the cluster. So we have that option. Note that if I enable that option for a private cluster, then the set authorized IP addresses here will be disabled, because I choose one or the other, not both of them at the same time. So I can keep my cluster public, and then I set up the IP authorized ranges right here. I can specify one or multiple ones who should have access to my API server. And then we have here another option for setting up the network policy. So either we say none, I don't want to install a plugin. And network policy, that's the tool that will enable you to manage how your containers or how your pods inside the cluster can communicate with each other. So it's like setting up a firewall rule inside your cluster. So to say the pod number 1 could connect to the pod number 2, but it could not connect to the pod number 3. So here it's the recommended way. Let's go continue with Calico. And then next for the integrations, so AKS is meant to deploy containers. Okay, so we need to connect it to a registry, so we can put the login and password of that registry. But if you are using ACR, Azure Container Registry, then here we can leverage the service principal, or even better, the managed identity, to connect to that container registry. And with that way, you will not save that registry credentials inside the cluster itself. So that add more security to your cluster. So if I go to create a new, it will go to create an ACR for me, and then bind it. I create the managed identity and then give it the right ACR pool airbag access. Next, here we have the container monitoring. So we go to disable this one for now, but the aim with container monitoring is that here it can use log analytics, Azure log analytics with container insights, to get or to collect the logs and the metrics from our cluster, and then send those data into log analytics instance, and then from there I can go to use Azure Monitor to view those logs, create dashboards, create alerts, and so on. For simplicity, I'll go to disable it, and then we have here another option for enabling Azure policy. So inside Kubernetes, we have a tool called OPA Gatekeeper. That is a tool that will enable you to create policies inside the cluster. Policies to say, for example, I should not deploy any application into the default namespace, or policies like saying I should add some specific labels to my workloads, to my pods, to my deployments. I should always use HTTPS for my ingress resources, and so on. So those kind of resources are enabled by OPA Gatekeeper. OPA Gatekeeper is an open source tool that you should configure it yourself. You should define the YAML files yourself. And here with Azure Policy, we are adding another layer on top of OPA Policy. And with that option, you would be able to manage the Kubernetes specific policies within the Azure portal through the Azure Policy. Let's keep that disabled for now, and let's move to the next advanced tab. So here, in the future, I believe you will see even more options here, but for now we have this single option for enabling secret source CSI driver. This will enable your pods to connect to a Key Vault instance within Azure in order to get the secrets or the certificates that will be used by the applications. Next, the tags, this will add the metadata to your cluster. And then next, if I go to review and create here, let's wait for until it tells me that this configuration is valid. Once that's validation passed, now I can go to create my AKS cluster, and this operation actually will take somehow between 4 to 5 minutes. And that is the time to provision the cluster. It means we'll provision the virtual machines, the virtual machine scale set, the load balancer, the IP addresses, also to create the subnets inside the VNet, and it will create the public IP addresses. So we have seen already multiple options for creating the cluster within the Azure portal, but yet all of those options are not all the options available for AKS. So if we go to this link for AZ AKS create, the command line for creating the cluster, we will see actually a long list of other options that are available for customizing your cluster. So going back now after 5 minutes to the cluster creation, we see here the different components of the cluster have been created successfully. So I'll go here to the resource group for my cluster. And then within this resource group, I'll find my AKS cluster and also the virtual network, as it will be managed by the user, not by the cluster. So when we create the cluster, we have actually two resource groups created. So if I go here to search for the resource groups within my subscription, we'll find one resource group that starts with MC for managed cluster, then the name of the resource group named the cluster, and then the location. And within this resource group, we'll find all the resources that will be managed by AKS itself. So it's AKS behind the scenes who are creating these resources and configuring them automatically for me. So these resources mainly would have the nodes of the cluster, which are Azure virtual machines used inside a virtual machine scale set, a VMSS. So if I go inside this resource here, I will find the instances of this VMSS. So if I go to instances, so remember I have created this cluster with at least 3 virtual machines. So it's normal that here I will find 3 instances of the cluster. And those instances might connect to other Azure resources through managed identity. So if I go to identity right here, user assigned, I will find one identity that is AKS cluster agent pool. That identity we can see it's the one available also right here. So that identity will be used to connect to the Azure Container Registry, for example, ACR. And then other resources are the load balancer. This is the load balancer that's going to be used by AKS, or to access the AKS, or to access also the services from my AKS cluster. So here we would have one or multiple IP addresses that will be used. So this is the default one used on my cluster, and this is the link for that IP address. By that IP address is also available as an Azure resource. That's a public IP address that have the same IP that we have seen earlier with the load balancer. We have also other resources like the network security group, the NSG, and when we go to enable other services or other features inside the AKS cluster, we will see even more resources that will appear here, like the application gateway maybe, or add some other managed identities or some other virtual machine scale sets if we create another node pool and so on. Let's now go back to the main resource group that contains my AKS cluster. So I'll go here to RG AKS cluster, and then I'll go to my AKS cluster. So within this overview window, I'll see the public endpoint for my cluster, the Kubernetes version, the network plugin for Azure CNI, the node pools created, and the name of the resource group, and the configuration of my cluster for the node pools, the networking section, and so on. So here what I want to do first is to connect to this cluster. So I'll go just to click on this button right here that will go to view those two commands in order to connect to my cluster. So I'll go to run the first command to set the subscription. So setting up the right Azure subscription. So if we have, this is useful when we have multiple subscriptions. So to not get confused, we set that right one. And then for the next command, we'll go to use AKS get credentials. Then the name of the resource group and the name of the cluster, and that will download the kubeconfig file that contains the credentials of the cluster. I have one existing, so I want to overwrite it, no problem. And then here, this is my kubeconfig file. We can view that file. If I type here cat, then the name of that file, then we can see this file actually will contain information like the name of my cluster, the public endpoint, and some other information like the client certificate. So keep this file secret, because anyone who have this file will have access to my cluster, as it have also a token right here. So now that we are connected to the cluster, we can use the kube control command line in order to get some cluster information like get nodes, for example, to get the nodes inside my cluster. And here we can see the 3 nodes that were configured. So now if I add to get nodes, if I add -o wide, that will add some more information to be displayed right here, like the IP address of those virtual machines and so on. So those IP addresses are the one from the virtual network subnet. Let's check that. So if I go back to my resource group of my cluster and then go to the virtual network, we would see that we have a subnet. So my VNet is under 10.10.10/0, and then if I go to subnets, I would see a subnet with 10.240.00/16, and that is where those nodes will take their IP addresses from. And by the way, you can see that same configuration if you go to the cluster, then node pools, then here we can see our node pool, and we can see also the 3 nodes right here, and we can go to each one and view even more details about each node pool. Where here we can see the zone where that node were deployed and its IP address, the version of the Ubuntu version that is used, the labels assigned to that node, and the version of Kubernetes version that is used there, and so on. Follow me in the next video to see how we can deploy pods or containers and then deploy deployments and services inside the cluster and see how those different components works together. Let's continue learning how Kubernetes works, where we go to deploy pods, deployments, and services and see how these components works together. So here I have in this GitHub repo, I share here all the commands that I'll be using for creating the deployments, creating the pods, getting the information, scaling the application, creating the services, exposing the service through a public IP address, and so on. And I have already created a Kubernetes cluster, and I have connected to that cluster, and now I'll go to deploy some resources. So just before doing that, I want you to know that when we create a cluster, we have already some resources that are created. So if I do here kube control get ns or get namespaces, we will see that we have some existing namespaces. The most used one is the kube system namespace, which contains already some pods running. So if I run here kube control get all from n kube system, get all, that's gonna get all the deployments, all the replica sets, the services, the daemon sets, the pods, and so on. So we can see here we have multiple pods deployed for Azure IP Mask, Cloud Node Manager, Core DNS, CSI drivers, Kube proxy, connectivity, Matrix server, and so on. So all of those are pre-created when we create the cluster, and those are system pods that are needed and that are essential to the good functioning of my cluster. Let's go now to create our own pods. So what I'm going to do here is that I'll go to use the command line to generate a pod, to generate the YAML file for a pod. So you can use kube control in order to create the pod within the command line itself, but in the Kubernetes world, we typically rely on the YAML configuration files because those are easier to configure, so I don't need to know all the options within the command line to edit it and to patch it and so on. So let's go to use kube control run. We'll go to run a pod called Nginx that is gonna use the image Nginx from Docker Hub, and then I'll output that run command into a YAML format, and then I'll use here dry run equal client to not run this command against my cluster, okay, but instead of that I go to output that command output into a pod onto a file called nginxpod.yaml. Let's go to run that. Once that file is generated, I can go to the folder where I have that generated file, and here I can see my nginxpod.yaml, and this is, let's say, the minimal configuration of a pod within the cluster. So I have here the API version v1, and then the kind is of type pod, that's the an object type. So when we deploy this, it's gonna go to create a pod within, let's say, somehow some sort of a table for saving all the pods inside the etcd in my cluster. Then in the metadata section, we have the name of that pod and then the labels associated with that pod. So if I want to route traffic to that pod, I should use the labels for that pod. And then I have some spec like the containers. So I want to run an Nginx container. I'll name it Nginx, and note that containers is with S, so it means I can deploy one or multiple containers inside the same pod. And here we have section resources that is empty for now, but here where we can specify the maximum or the limits of CPU and memory utilization, and then some other couple of configurations like DNS policy and restart policy to say always, so each time we have a problem in this pod or crash, it should always restart the pod. So let's go now to deploy this pod. So again, I'll use the command kube control apply -f and then the name of that Nginx pod file. Once it's deployed here through this success message, I can go to kube control get pods, and that's the command we use in order to get the pods deployed into the default namespace. So by default here, this pod will be deployed into a namespace called default unless I specify another namespace. So we'll continue working on that on that default namespace for simplicity. And here we can see my Nginx pod is running and it's ready, and yeah. So in my cluster, because I have used the CNI plugin, the Azure CNI plugin, so it will get an IP address within the virtual network. We can view that IP address if I reuse the same command and then I add -o wide to show even more information. And here we can see, here we can view that IP address, and we can also view the node where this pod were deployed to. Remember that IP address is within the subnet of my virtual network cluster 10.240.0.0. Great, so that is a pod actually, and that is the unit of deployment into the Kubernetes cluster. But in the real life, we don't deploy pods like that because it will deploy only one single pod, and we have a best practice in Kubernetes to deploy at least 2 replica of the pod. So, and in the real life also, we would need to scale out and scale in those number of pods. So we should use another type of object that will enable me to scale out. That type is the replica set, but the replica set will enable just scalability. So, and sometimes we need to add some other features like the environment variables, like the mounting the volumes and so on for those different pods. So in that case, we'll be using another type of object, which is the deployment. So we would have the pod inside a replica set, and then the replica set is inside the deployment. So in real life, we would use the deployment inside the replica set and instead of the pod. Even if we want to deploy one single pod, we would use deployment for that, so we'll be able to scale it later. So let's go to create a deployment. So for that, I'll be using the command line kubectl create deployment nginx deploy. I call it nginx deploy, and again I'll be using the image nginx for simplicity, and then the number of replica is 3, so I want to create 3 instances of that nginx pod. I'll output it in YAML and then try run equal client to not run this command against my cluster, and that will go just to generate the YAML file for me. Let's run this command, and here immediately we can see a second YAML file that is created here. It's of type deployment, and it have some metadata like the name of the deployment, the labels for this deployment, and then for the spec we have some new values here like the replica, which is equal 3, and then the labels for the labels for the deployment, the labels for the pods, and within the spec we have the same configuration as we have seen with the pod earlier, like the name of the image and the image nginx itself. Let's go to deploy this deployment resource. So I go to use kubectl apply -f and then the name of the nginx deploy YAML file. So as before, to make sure this was really deployed and deployed successfully, we can use kubectl get. As we have get pods, we have also get deployment or get deploy as a short name, and here we can see our deployment were deployed successfully. So I have here 3 pods running and ready. So it means that now I have 3 additional pods in my cluster. So if I do get pods -o wide, then I see my nginx pod in addition to the 3 pods deployed with the nginx deploy. Note for these 3 pods, it's using the generated name, which is going to contain the name of the deployment, then pre-generated ID for the deployment, and for each pod is generated randomly generated ID right here. And you can see here each pod would have its own IP address, of course, and because each pod and here each pod also is deployed into another virtual machine. Not all of them are deployed in the same virtual machine. So here Kubernetes, its scheduling mechanism will make sure that it will spread those pods across the different virtual machines that they have, and that in order to enhance the availability of my applications and of my pods. So now I want to do an experiment. What I am gonna doing here is that I'll go to run inside the nginx pod. So that's my first pod right here, using the kubectl exec command that will enable me to access inside this pod and get access to the shell of that pod, and using the interactive mode. So let's go to run that. And here, note how the shell changes. So now I am inside the pod or inside the container in my AKS cluster in Azure. If I type ls, I will see the folders coming from the Linux container. So from within containers in Kubernetes, our pods can communicate with each other. So I can have this nginx pod communicating to the other pods from my cluster. So let's try, or let's see how that works. So each pod has its own IP address. I can connect to that pod through its IP address. So if I try here to do curl, and curl is already installed in the nginx pod, and then if I try the IP address, then here, I can see the output of the nginx pod displaying welcome to nginx. So this is to say that all pods within the cluster can communicate with each other. Even if these pods are within different namespaces, they still can communicate. And in order to limit this communication, because you might have different applications and you want to isolate those different applications, then you might use something like the network policy using Calico. Let's exit from inside this cluster, and or from within this pod, and let's explore some other useful features within Kubernetes, which are the scalability. So in Kubernetes, we can scale out the number of virtual machines, and we can also scale the number of pods that we have inside the cluster. Let's explore this latter option. So in order to scale the number of the pods, I'll go here to clear, and then we can use the command kubectl scale my deployment that is called Nginx deploy, and I want to specify the number of replica to be 5 instead of 3. So let's go to run that command, and here it tells me that deployment were scaled successfully. So if I go to check that, if I do kubectl get deployment, I would see that now I have 5 pods running instead of 3. And I also can do kubectl get pods -o wide, and from here I can see now I have 5 pods running, each one have its own IP address and assigned on a virtual machine. I can also go to scale down those number of pods. So instead of 5, maybe now I just need to keep 3 pods. So with this option now Kubernetes will go to choose to kill 2 pods in my cluster. So here if I do get pods -o wide, then here, yeah, it did actually choose 2 pods to kill. So you note here each time we scale the pods, or each time we the pod could be scheduled into another virtual machine, its IP might change. So the IPs of those pods might change. So if I want to communicate with that pod, I will not rely on this public or on this private IP address. So I need to rely on something that doesn't change, and that is the service object. So let's explore how the service works. So the service is like what we have with the DNS service names, where instead of using the IP address of the server, we go to create a service name like mycompany.com, and that domain will map to the IP address, to the real IP address of the server behind it. So that if that IP address changes, then we would have some process that will update the new IP address. And that's the same of what is happening in Kubernetes. So here I'll go to create a service by using the command kubectl expose, and here I can expose a deployment or a pod or a replica set and so on, and I call that Nginx. I expose the deployment, call it Nginx deployment, and I call that service Nginx-svc, svc short name for service, and then I expose it on the port number 80, and then I'll use here dry run equal client, and I'll output that service into a YAML file. Let's run that command, and that will go to generate the service.yaml file for me, which is the one right here. So it's of kind service, that's the Kubernetes object. It have a name, and for the spec here, it would have the ports that will be exposed by that service. So it will be exposed on port 80, and it will redirect to the pods that have the port 80 exposed. So it will redirect to the pods through the selector. Note here we are not using the name of the deployment to identify those pods that it wants to route the traffic to. So instead it's using the selector, which is app nginx.deploy, and if I go back to that deployment, note here it's using that same label app nginx.-deploy. Let's go now to apply that service. So if I do kubectl apply -f, then here enter the name of that service. Once that's deployed, I can go here to kubectl get service or get svc, and then here I would see my Nginx service running in my cluster exposed at port 80, and then running at the service at the IP address 10.032.188, and that is different from my subnet IP address, because here the service is not it will not consume IPs from my virtual network. Instead, it would use an internal network for the cluster that will be used only by the services inside the cluster. And that is the service CIDR range that we can see it from the portal, from the AKS portal right here. So it's 10.00/16. So this service will go to route traffic to the pods, or to my 3 pods from within my deployment. Let's see how that works actually. So here I'll go to run the command kubectl describe service Nginx. Sorry, it should be Nginx-svc, that is the name of my service. And from here we will see general information like the selector that is used to route traffic, and then the most important part here is the endpoints. So here we can see the 3 IP addresses of our 3 pods backed by the deployment. So the service here will act like an internal load balancer for my cluster that will go to route traffic into the 3 pods using these 3 IP addresses. And of course, if these 3 pods changes their IP address, then the service will go to update this list of IPs. So now, as I said, we create the service in order to enable communication with other pods that are changing their IPs, and this means I can use that service name in order to communicate. So let's demo that. So for that end, I go to use exec, or I'll exec inside the Nginx pod that I have used before for accessing to the other pods. And now I'm within that Nginx container, and from here I'll use curl, but I will not rely anymore on the IP address of the pods, but instead I will use the service name, which is Nginx service, with HTTP, of course. And then here, yeah, we get that HTML output from the Nginx pod backed by the deployment. So here it's routing me to one of these 3 pods of the cluster. If I run that command again, it will route me to the second instance, the third instance, and so on. So it's using the round robin. Let's now go to exit from this pod. Let's go clear this, and let's go run again the command for describing the service. And here we will see another detail, which is the type of this service. So the type here is using cluster IP, but we have also other types. So cluster IP will keep that service and accessible only through the resources inside the cluster itself. So now I might have another use case where my users connected on the internet, they want to use or to connect to this service. So in that case, I should change the type of this service to be a load balancer, and that will go to create a public IP address for to access this service. So let's see how we can do that. So we'll be leveraging here the command kubectl edit, then the service Nginx SVC. And note here that we'll go to load the YAML definition of my service right here of the Nginx SVC, and I can go to change inside this file directly. So I can go here to the type and change its type from instead of cluster IP, let's go to command that, and then use the type load balancer with capital L and B, and then Control S to save these changes. And then when I close this file, it will go to save those changes. It tells me here the changes were made successfully. So now if I go to describe again the service, we'll see the type now is load balancer. And we'll see here an event that will appear telling us that the service name were changed from cluster IP to load balancer. Note that the service would keep its own private IP address, okay, and in addition to that we'll add another public IP address. If you want to see that public IP address, then we'll go to use another command, which is kubectl get svc and then -w in order to wait for the creation. And here, yeah, it was created successfulully, and we can see the external IP in addition to the private IP of the service. It's this IP right here, 20.76.235. If I go to launch that service, then here we can view the welcome to Nginx HTML output from my Nginx pod. We can also view that service if we go to our Kubernetes cluster, then services and ingresses, and here we would see the Nginx service with its IP, internal IP, and its public IP. And if we go to workloads, then here we can see the pods and the deployments that we have created during this workshop. We can also view the pods here coming from all the namespaces, and we can also filter on a specific namespace like the default one where we can see our 4 pods deployed. Another interesting detail, actually, when we have created the public service of type load balancer, that did create actually public IP address. So if I go to the managed container resource group right here, we will see that we have now a new resource added, which is of type public IP address, which is the IP created by AKS in order to get access to this service. And that IP address were used inside the load balancer. So if I go here to the load balancer front-end IP configuration, you will see here that second IP were added to that load balancer. I hope this demo was helpful. Thank you.